true risk of meteor impacts, I'm just going to read the table fast and give you a conclusion. Let's do this. Size versus frequency of stony asteroid impacts, or if they're even called that. The hit or impact thing is in quotes. 4-meter items hit once a year and airburst, these are 13-footers, they airburst at about 140,000 feet. They're sometimes not even audible. In fact, most of the time they're not. Every 5 years you get one about 7 meters across, and they airburst at 120,000 feet. You might hear them. At 10 meters across, once every 10 years, nice round numbers here in this case, they airburst about 100,000 feet up, or 98,000 feet up. But who cares? 1,000 here and there. At 90,000 feet up, you get once every 15 years a 15-meter one. Again, nice round numbers. At 20 meters, it's not 20 years, it's about every 60 years, we get one that's exploding at 75,000 feet. The 66-foot Chablansky meteor that went over Russia dropped some small gravel, created a huge airburst, blah, 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 and it blew up at about that. That's a good example of one. Now, depending on the actual density, they may be more dangerous if they're lighter weight or less dangerous. The more dense the material, the more likely it is to come into the atmosphere deeper and cause more damage at lower altitude. But we're still at 75,000 feet. Not going to hit Everest. At 54,000 feet, the 100-footers burn up once every 185 years. That means we have really, we're about due to have one airplane hit, something like that. And those are the 30-meter ones. At 30,000 feet, we get burn-ups of 160-foot across ones, or about 50 meters. This happens once every 760 years. And might be able to do something at an altitude where Everest or K2 would be hit by some material at 30,000 feet. We're getting close to that range. We're not talking about actually hitting them at that altitude. But it might. But the amount of material land at that height above sea level, at that air pressure, which would cause burn-ups, is literally just a couple of mountaintops. The most likely thing would be gravel. Now, I want to point out that since this only happens once every 764 years, and we're in the year 2000 and such, that works out to, being close to about the time when writing started. And there is recordings of something like mountains shaking and gravel falling and a blast of light when it wasn't a volcano ever or since. So we have maybe evidence of recorded history indicating something that low to the ground, 30,000 feet. Now, there is one other exception to that. At 33,000 feet, at 60 meters across, which is the midline here, you would think these would burst at a lower atmosphere altitude like 2,000 feet. But this one burst, we have a record of this, in 1908, Tuskegee. It was a vertical hit at 12 megatons, and it was mostly a comet, so it was lighter weight, but it burned off material, which made it go through the atmosphere easier, and then it burst at 33,000 feet. So it's, again, the density and stuff. This was a 200-footer, and it flattened an area that's like 30 miles across. And on record is potentially 3 deaths and of 3 humans and a dog. Or not. Now we get to the point we're talking about 70-meter impactors or items. They're 230 feet across. They may hit a mountain range top and or drop gravel to the ground. These are at 12,000 foot airburst, and they happen every 190 to 2,000 years. We don't have any records of this really happening. I mean, dramatic explosion in the mountain range that would be visible because this is only 12,000 feet up. You would hit mountain ranges. We don't have very many records of this sort of thing. The only thing close to that is turning your back and looking back and becoming a pillar of salt, or a flashover effect, or a city being destroyed by something very much described as fire and brimstone, aka an airburst, obviously from a slightly bigger cometary one that would really literally go off like an atom bomb. These are on a range of over 12 megatons. 20 megaton explosion at high altitude would flash burn an entire valley. Those would be stories you want to look into. But that's 2,000 years ago. We're at the upper limit for where you can look back in time and find anything even similar. At 3,300 years apart, we get our 85-meter across ones. These are the 280 to 300 footers. These are about the size of a football field. They explode at 2,000 feet above sea level and could obviously flatten and destroy an entire, immediately flatten everything in an area. These would not be exempt from being recorded and could potentially flatten an island where you couldn't see it anymore. And would be Krakatoa level explosions. We're talking 20, 30 megatons, that sort of thing. Potentially. Depending. They'd have to be an actual comet, which means you would see it. Virtually everything I've described to you up to this point wouldn't be visible up to 40 seconds to 2 minutes before impact. You would not notice it. It wouldn't be a dot in the sky. Let me explain that in a minute. But anyway, at 2,000 feet, 180 footers can hit land easily anywhere. Now, I want to remind you that every 3,300 years apart works out with 2,000 years to be about the time when we had the first written symbols and writing that would be easily translated to get a narrative if you worked at it. And we do not have any records of this happening except, obviously, stories that were handed down verbally of cities being flattened. So there is some basis for this, but most of this would be turned immediately into mythology because we didn't have full writing that would be considered real writing in literature and recorded history till, well, here we go. Actual impactors, football field size, atom bomb explosion-like things every 52,000 years. 100 meter across. 130 meters or 400 footers. These are city killer nuke levels. These would absolutely destroy an area that would be impossible to ignore and be detectable from over the horizon. And if you had an area that was, well, the thing is we're at the 11,000 year mark. At 10,000 BC, humans started to live in villages and agriculture was invented. And that's long before we had any real examples of writing. Then we get the 500 footers. These are H-bomb level, not nukes, not atom bombs. Hunter-gatherer era, 16,000 years apart, 150 meters across. After that, we get things that are like the Sarbama level, every 60,000 years, that would be impossible to not know about all over the planet because it's just big enough you'd hear the explosion all around the world. These are the 1,000 footers, 1 kilo footers. Everything beyond that would be impossible to not know about. These are the ones that would cause destruction on a ridiculous level. 200-meter ones would hit every 36,000 years, which is the max range for verbal history recording and passed down from generation to generation things. Now let's talk about where people live. Throughout time, human beings have avoided work. We're lazy. We walk everywhere because it's a lazy way of moving. We tend to follow rivers, streams, and old valley bases that had streams in them because they gently go up and downhill. Those are our passageways. They're long-form versions of passes between mountain ranges. We also stay near shorelines, lakes, because there's water, because there's food, because there's housing, because there's shelter from the weather. 300 feet or 100 meters above sea level holds about 16% of all currently inhabited land. 33% of the world's population is within that narrow band from 300 feet or 100 meters down to the ocean level. Yes, I know they're not equivalent. There's this banding and variation, so I'm just integrating it by using the next round number. The median occupied elevation is 600 feet to 200 meters above sea level or below. This decreases with elevation heavily. That means 2,000 foot impact altitude isn't good enough to get anybody to notice it in the past because people wouldn't have been at those altitudes and they would have been between mountain ranges to shield themselves a lot, or hills. Even a small hill would blind you, keep you from seeing anything. There's a YouTube video where someone tried to simulate the effect of a planet killer or a dinosaur killer impactor as viewed from France and as viewed from Florida. The only way to show it on screen to where you'd see a goddamn thing at all to make it an exciting video was to make it a comet. Like the Tuskegee event would outmoded its normal altitude of burst because it burst lower even though it was fluffier. It was a snowball, but it hit, detonated, and flattened more. A comet impact would have a massive history of information about it. You're all looking up some songs and some stories now? Huge 600, 500-mile asteroids in the main asteroid belt between Mars and Jupiter are stuck there. They pose almost no threat. Even if they bonk into each other, their inertia won't allow them to do it because all of the bonking around and jostling has happened over 13 million years or something. The size of an approaching asteroid affects the amount of time we would have to see it coming, mostly based on light bouncing off of it. Missed asteroids tend to be small, unimportant, generally having little damage potential of any kind. The size estimates of most near-Earth asteroids are based on visible light only. This is a problem because the sun is shining primarily on the side facing away from the Earth. The object could be anything from 50 to 200% of the estimated diameter, therefore we'll get it wrong a lot of the time. Due to error, thermal infrared surveys from the land and space are needed. As of now, there aren't any in use or available as far as infrared space-based, specifically for locating near-Earth objects that could be a major problem. The number of detections is increasing as more survey sites come online since the early years of the 21st century. Just the last 22 years, 21 years. Half the asteroids that were detected closer than the moon's orbit, which means we should have paid attention to them, were only detected after they'd already gone past. Like asteroid 2018 AH, which is 100 times more massive than the Chelyabinsk meteor, was detected 2 days after it had passed. It would have been a city killer. We wouldn't have known it. We would have just heard an explosion and then found out after the fact what happened. From 2008 to 2019, a little over 10 years, we've successfully predicted the impacts of 4 or 6 asteroids. 4 of them were actually real. 2 of them were because they should have made an impact noise or something. One of them we detected strictly because of the light angle was 10 to 40 centimeters across. The other one, we don't know if it hit. The 2 of them, 2 out of the 6, we don't know if they hit because we had no detection of impact, which means they were nothing. At best, we get a 14-hour average head start or heads up warning. Usually it's a day to a week warning minimum. That's it. We don't get enough time to do a damn thing about the impactors currently. So let's fund Space Force instead of space-based telescopes that are boring and actually save our asses. I want to point out that with the tilt of our solar system like that, 60 degrees out of phase with the galaxy, and a bunch of information you can look up, we have a galactic year. If you predict that the galactic year has something to do with us being lined up with some stream of matter, the galactic year works out to 230 million years, so it doesn't coincide in any way with the 65 million year impactor from the impact that took out the dinosaurs. And that's really all there is to it at the end of the video. There isn't any predictive programming, Mandela effect, conspiracy theory YouTube channel that actually tells you any of this. Now the thing is, this is based on people studying actual impact sites, figuring out when they happened. Well, that's science. I don't want to believe in it. I don't give a shit. Within the lifespan of since Jesus Christ, we have maybe 230 footers that burst at 12,000 feet and may hit mountain ranges. Within the entire history of humanity, we could have a football-sized impactor once. An atom bomb-like explosion because a 300-footer hits that should have been recorded within recorded history for like 3000 BC. After anything bigger than that would do any real damage. I mean, we get this massive cutoff where anything that would hit the ground is extremely rare. We don't even have confirmation of impactors within human lifespan. Saying that this is predictive and it happens every 16,000 years or some other made-up number is horseshit, because there aren't any previous examples that actually check out. Within the approximately 10,000 BC to today, we have 400-footer city killer nuke types that would have been easily ignored because they hit an area that simply wasn't occupied. They don't have to hit anywhere but the ocean. They would be more likely to hit the mountain ranges. And because people stick close to mountain ranges and hills, you wouldn't be in line of sight with any of it. And again, you'd get really, if you weren't sci-fi capable like we are now, you'd get a 1 or 2 minute warning, and all you'd see was a dot, then a bright flash, and then you're melted. But yeah, let's ignore science and history and recorded history especially, and even the Bible, because we need some conspiracy theory to sell views on YouTube. No, you're not in danger immediately. No, there is no cyclic nature to any of it. And no, we're not due for anything. Thanks for watching. Have a good day. Good luck with all.